Using artificial intelligence over the last couple of years has felt a bit like giving a highly literal, incredibly dense dictionary a set of just hyper-specific instructions.
Oh, completely. It was exhausting.
Right. Like if you didn't phrase your request perfectly with the exact right syntax and honestly like 10 paragraphs of background context, you'd just get absolute garbage back.
Yeah, you basically had to become a programmer of words just to get a simple email drafted.
Exactly. But looking at this massive stack of announcements we're diving into today, from OpenAI, Anthropic, Google, the whole open source community, it really feels like that era is officially ending.
It really is. The paradigm is shifting completely.
Yeah, because now it's becoming more like working with an intuitive assistant who can actually read the room and honestly almost read your mind sometimes. Welcome to today's deep dive, everyone. Our mission today is to sift through this huge week in AI, pulling from Matt Wolf's AI News Rundown, and really figure out what this means for you, the learner.
Right, because we want to cut through all the overwhelming noise, all the benchmark numbers and the heavy tech jargon.
Yeah, nobody wants to just hear a list of numbers.
Exactly. It's a fundamental shift, really, from the AI interpreting what you say to the AI actually understanding what you mean. We're moving away from having to adapt to the machine's limitations.
Which is such a relief, honestly.
Oh, for sure. Now, the machine is adapting to your implicit intent, and the sheer volume of updates from this week perfectly illustrates this transition.
It really does. The stack is just massive, so let's get right into it, because to really understand the shift from, a literal dictionary to an intuitive assistant, we have to start with the most famous tool of them all.
Right. OpenAI's latest drop.
Yeah, they just released a major upgrade. So what exactly are we looking at with GPT 5.5?
So GPT 5.5 is currently rolling out to Plus, Pro, Business, and Enterprise users. And API access is coming shortly. But on paper, it is absolutely dominating the technical benchmark.
Like wiping the floor with them.
Pretty much. For example, it just scored an 82.7% on Terminal Bench.
And for the listener, that's a coding and reasoning benchmark, right?
Correct, yeah. And that 82.7% is a really big deal because it actually beats Anthropic's unreleased, heavily hyped Mythos model.
Oh, the scary one.
Right, the scary one, which scored an 82%. And 5.5 also just took the absolute top spot on the Artificial Analysis Intelligence Index. It got an extra high rating, breaking this previous three-way tie.
Wow. So objectively, structurally, it's the smartest model available right now.
It is. But what's fascinating here is that the average user might log in and just feel like a slight vibe change. The real revolution of 5.5 isn't just the raw intelligence.
Okay, then what is it?
It's the efficiency.
Yeah.
The biggest real-world takeaway from this update is that you can do significantly more with less.
Right, and I want to make that tangible for the listener because doing more with less can sound like a total corporate buzzword.
Oh, absolutely.
So what does that actually look like if I'm just sitting at my laptop trying to get something done?
Let's look at a specific real-world test that perfectly captures this. So imagine going to the older model, GPT 5.4, and typing an incredibly vague prompt, just one sentence, like, help me build a plan to be healthier.
Okay, literally no context, just vibes.
Exactly. No context, no parameters. With a prompt that vague, 5.4 gave exactly what you'd expect, which is generic advice.
Like drink water, get better sleep.
Right. Eat cleaner, do some daily movement. It was just a boilerplate 30-day plan you could find in any fitness magazine at the grocery store checkout line.
Which makes sense because you didn't give it any data to work with.
Exactly. But when that exact same highly vague prompt, help me build a plan to be healthier, was fed into GPT 5.5, the response was entirely different.
Oh, really? What did it do?
It didn't give generic advice at all. Unprompted, it dug deep into that specific user's past chat history across months of interactions.
Wait, it just pulled that from random past conversations?
Yes. It replied with something like, your biggest nutrition issue historically isn't that you eat too much junk food, it's that you often skip meals.
That is wild. It just knew that.
It knew that. It's
Yeah.
that you undereat protein during the middle of the day and you consume the vast majority of calories late at night.
Wow. It just inferred all of that necessary context without being explicitly told to go look for it.
Precisely. And for the workout plan, it specifically adjusted the user's schedule. So the ideal high-intensity workout days were Tuesday, Wednesday, and Friday.
Okay, why those days specifically?
Well, it deliberately made Monday and Thursday light movement days because the model knew purely from past context that the user edits their YouTube news videos all day on Thursdays.
Shut up.
I'm serious.
Yeah.
It knew they wouldn't have the energy on Thursday.
Okay, let's unpack this, because there's a massive catch here that we really need to talk about. We have to look at the pricing for this level of intuition.
Ah, yes. The token costs?
Right, because GPT 5.5 is currently priced at $5 per 1 million input tokens and $30 per 1 million output tokens.
Which is a significant bump.
Yeah. And for the listener, a token is basically a fragment of a word the AI uses to process text. But that pricing is exactly double the cost of GPT 5.4, which was sitting at $2.50 and $15.
It's exactly double, yeah.
So if the price is doubled, aren't we just paying a massive premium for a vibe change and slightly better mind reading? How does the math actually work out in the user's favor here?
It's a really great question. And it comes down to this concept called token efficiency. Yes, the raw cost per token has absolutely doubled.
Right.
However, you have to look at the overall cost of completing a specific task. Think about how you used to interact with 5.4.
Lots of back and forth.
Exactly. You write a prompt, get a mediocre result, write a refinement prompt, get slightly closer, tell it to fix a bug, and so on.
Yeah, you might spend 5 or 6 turns burning thousands of tokens each time just trying to steer the machine.
Precisely. You're paying for all that friction. But because GPT 5.5 understands your vague intent on the first try and retrieves its own context, you aren't spending tokens on those 5 or 6 refinement prompts.
Oh, I see. So it gets to the finish line faster.
Exactly. We saw this in another test regarding coding. A user gave a really vague prompt to create a beautifully designed interactive website that visualizes the model's capabilities.
Okay. Pretty broad.
Very. 5.4 built a slightly wonky, flat design with weird overlapping text.
Typical old AI behavior.
Right. But 5.5, with that exact same low-effort prompt, built a fully interactive node-based graph. It had a functional fit score slider that dynamically updated the data as you clicked around.
It just figured out what beautifully designed and interactive actually meant.
Yes, in a modern web context.
Yeah.
So you're paying more per step, but taking far fewer steps to reach the destination.
That makes total sense. So if language models are getting this much better at understanding implicit intent with less hand-holding, what happens when we take that autonomy and apply it to complex, multi-step environments?
That is where things get really crazy.
Because it seems like we're moving away from just predicting text and moving into managing actual tasks.
Yes, we are entering the agentic workspace. And to see how this works in practice, we really have to look at the new updates to Warp.
Warp, which is a popular terminal for developers, right?
Right. It's basically the command line interface where you write and execute code.
Mm.
And they just updated their system to support universal agents.
And from what I understand from the rundown, this completely changes the workflow. Up until now, if you used AI to code, you had a chat box on the side, right?
And it was super disjointed.
You copied code from the chat, pasted it into your project, tested it, found an error, copied the error, pasted it back into the chat. I mean, it was exhausting.
It was an incredible bottleneck.
Mm-hmm.
But inside Warp now, you can run different AI models like Claude Code, Codex, OpenCode, all side by side in vertical tabs within the environment itself.
So you aren't just chatting anymore.
No, you are deploying agents. You could have one agent writing a new feature, while a completely different agent is running diagnostics and debugging in the background.
That's incredible.
And Warp introduced inline code reviews, meaning the AI's comments update your code base instantly.
It's like we've upgraded from having one really smart intern that you have to micromanage constantly to managing an entire bullpen of specialists who now have their own desks via Warp.
That is a perfect analogy.
They're just working away in the background. But wait, if you have all these agents running around changing your code, how do you not lose control of the project?
Well, that's where the unified notification system comes in. You don't have to constantly babysit the AI.
Oh, thank goodness.
Yeah. It operates autonomously until it reaches a critical decision point or encounters an error it just can't resolve. Then it simply pings you, asks for a human decision, and goes right back to work.
Wow.
If we connect this to the bigger picture, AI is fundamentally shifting from a standalone application you visit to a swarm of invisible workers operating simultaneously inside your native applications.
And what blows my mind is that this isn't just happening with proprietary, closed models from massive companies.
Not at all.
The open source community, specifically the open weight space, is absolutely exploding with these agentic models.
The open weight releases this week were staggering. And For the listener, open weight essentially means the underlying mathematical architecture of the AI is available.
Right, so developers can download it, modify it, and run it locally on their own machines.
Exactly, rather than having to send data back and forth to a server owned by OpenAI or Google.
Which is huge for privacy. And one of those drops was Kimi K2.6, which is an open-weight coding model.
Oh, Kimi is fascinating.
According to the rundown, this thing can run 300 parallel stub agents. 300.
It's a massive number.
How does a system even coordinate 300 agents without completely collapsing in on itself?
It uses a hierarchical structure. You see, you aren't giving instructions to 300 individuals. You give a high-level goal to a manager agent.
Oh, so it delegates.
Exactly. That manager breaks the goal down and delegates it to specialized sub-agents. So maybe 50 agents are dedicated strictly to researching documentation, and 100 are writing specific microservices, and another 150 are running constant automated testing.
That is just wild to think about.
And Kimi K2.6 is doing this so effectively that it's beating state-of-the-art proprietary models like Opus 4.6 and even GPT-5.4 on major benchmarks like Deep Search.
Man, and it's not just Kimi either. Alibaba dropped Qwen 3.627b, which is also just crushing older models in agentic coding.
Yeah, Qwen is very impressive.
And Google introduced DeepMind Deep Research Max, which is a fully autonomous research agent. I mean, the ecosystem of these independent digital workers is expanding exponentially.
It really is. And even OpenAI is leaning into this localized specific autonomy. They released something called the OpenAI privacy filter.
Which is such a brilliant tactical move. It's an open-weight model specifically designed for masking personally identifiable information, or PII.
Right, so think about the enterprise applications there.
Exactly. So if I'm a hospital or a law firm, I can download this model, run it locally on my company's server, and it will scrub names, social security numbers, and medical data from my documents before I send those documents to a larger cloud AI for analysis.
Precisely. The sensitive data never leaves your machine. The localization of AI is really the master key for enterprise and healthcare adoption.
It really solves that huge compliance hurdle.
It does. In fact, OpenAI also just rolled out a free version of ChatGPT for verified U.S. clinicians, specifically to handle medical documentation natively and securely.
That's amazing. But, going back to your analogy of managing a bullpen of 300 sub-agents.
Yeah.
So here's my question about that. If I'm listening to this and my daily workflow is mostly like Excel, basic project management, or marketing copy.
Right, non-technical stuff.
Yeah. I might hear 300 parallel sub-agents coding and debugging and honestly feel a bit panicked. With these systems becoming so complex, does this mean non-technical people are going to get left behind? Or does this actually lower the barrier to entry for everyone else?
Oh, it entirely lowers the barrier. Think about how software has historically been built. The barrier was the syntax, right?
Knowing the code.
Yeah, knowing the specific programming languages required to make the computer execute your idea. But when you are managing an agentic swarm, you aren't writing syntax anymore.
What are you doing then?
You are setting goals, defining constraints, and reviewing outputs.
Well, so the skill shifts completely.
Exactly. The skill shifts from knowing how to code to knowing what needs to be built. It democratizes creation.
That is so empowering.
The technical execution is handled by the agents. You just need the vision, the domain expertise, and the logical thinking to direct them.
That makes a lot of sense. And speaking of vision and creation, it's not just developers who are getting these autonomous, highly capable tools.
Oh, no, designers are right there, too.
Right. If the developers are getting a bullpen of coding agents, the designers and creatives are experiencing the exact same leap this week. We are moving from AI generating things to look at to generating things you can actually use.
Visual and functional independence.
Yes. OpenAI rolled out ChatGPT Images 2.0, and according to the rundown, this thing completely obliterated the competition on the LM Marina blind taste test.
That was quite the jump.
And for context, the LM Marina is basically crowdsourced vibe checking for images. Users are shown 2 AI images blindly, and they just vote on the best one.
It's the gold standard right now.
Yeah. And Images 2.0 scored a 1,500. It dethroned the previous champion, Nano Banana, which was sitting at 1,271.
Nano Banana. I love that name.
I know, it's great. But that is a massive jump in a benchmark where progress is usually measured in like single digits.
It really is. The key here is to understand why it scored so high. OpenAI describes Images 2.0 as having explicit thinking capabilities and actual world knowledge.
What does world knowledge mean for an image generator?
Well, traditionally, image models are diffusion models. They start with TV static, and they slowly denoise those pixels until they form a pattern that resembles your prompt.
Right.
They don't actually know what a cat is. They just know the statistical arrangement of pixels that humans call a cat.
But Images 2.0 is doing something different.
Yes. It's pulling in real-time information and logical structure to construct the image. For example, someone asked it for a messy Mac OS X desktop with a terminal open and ChatGPT in the foreground.
And it didn't just make a blurry approximation of a screen.
No, it generated an image with a structurally perfect dock, coherent overlapping windows, and terminal code in the background that actually made syntactical sense.
That is insane. There was another example that blew my mind too. The visual polyglot magazine collage.
Oh, that was a gorgeous image.
The prompt asked for a dense collage of information, and the model packed the image with anatomical drawings, old maps, climate charts, transit signage. And it wasn't gibberish.
That's the crazy part.
The climate charts had proper axes, the dense information was actually coherent, but the absolute most staggering example of this world knowledge is the barcode test.
Oh, yes. This test perfectly illustrates the shift to functional utility.
Okay, here's where it gets really interesting. A user prompted the model to generate an image of the back cover of the business book, Good to Great.
Right.
But they specified that the barcode on the back of the book had to actually scan to the real-world book.
Which sounds impossible for a pixel generator.
Totally. The AI generated the image. The user literally took their phone, scanned the AI-generated barcode right off their computer screen, and it perfectly pulled up Good to Great.
And just to prove it wasn't a fluke.
Right. They did it again with the finance book, The Intelligent Investor, and it scanned perfectly again.
Unbelievable.
Then, to prove the phone wasn't just using optical character recognition to read the human-readable numbers printed below the barcode, the user took the image, blacked out the numbers at the bottom, and scanned just the raw black and white vertical lines.
The ultimate test.
It still worked. It went straight to the Intelligent Investor. So, explain this mechanism to me. How is a visual model something that is supposed to just denoise pixels generating a mathematical barcode without just copy-pasting an ISBN string from a database?
It's wild, I know.
Is it actually understanding the mathematical structure of barcodes?
That is exactly what it is doing, and it is a massive breakthrough. It's an image model predicting utility.
Wow.
Because this model has deep world knowledge, it understands that a barcode isn't just a visual texture of black and white stripes.
Right.
It knows it is a mathematical encoding of an ISBN number. It knows the ISBN for the Intelligent Investor, and during the generation process, it is actually applying the algorithmic rules for translating that specific number into the exact spatial widths and spacing of barcode lines.
Wow.
It bridges the gap between mathematical logic and spatial geometry.
Right.
It's literally encoding real-world functional data into a visual format.
It's generating utility from thin air, and Anthropic is right there doing the exact same thing for UI and web design.
Yes, Claude design.
They just released it, powered by their new Opus 4.7 vision model. And this isn't just making pretty flat pictures either. It's generating functional UI, interactive product wireframes, and even complex animations.
This solves one of the biggest bottlenecks in design, which is moving from a static mockup to a functional prototype.
Exactly. A user prompted Claude Design to reimagine a tech directory website. And it didn't just give a flat JPEG mockup, it built an interactive site with a functional stop chart ticker, showing how different AI tools were trending.
That alone is impressive.
But the craziest part was the animation capability. Someone used it to build an After Effects-style animation for a panel at the upcoming NAB 2026 conference.
Right, I saw that video.
They told it to highlight Las Vegas on a map, zoom in, drop text, and generate animated bar graphs showing AI attendance year over year. Claude Design just built the entire animated sequence from a few simple text prompts. How does an AI know how to animate a graph?
It really comes down to frame prediction and understanding physics. What used to take hours in complex keyframe animation software is now being generated through conversational intent.
It's just wild.
The model understands the physics of a camera zoom, the mathematical timing of a bar graph rising to represent data, and how to sequence those visual events logically over time.
So on one hand, we have models that can coordinate 300 agents to code entire applications, models that generate mathematically perfect barcodes from scratch, and models that animate data visualizations just by chatting with them.
It's hard to process.
We're reaching a level of digital capability that feels, frankly, a little like sci-fi. Which brings us to the corporate drama surrounding all of this, because the tech CEOs are definitely leaning into that sci-fi narrative.
Oh, absolutely. The contrast between the digital capabilities we've been discussing and the physical realities of AI is quite stark, especially when you look at the marketing rhetoric.
Exactly. Let's look at the hype machine. A couple of weeks ago, Anthropic hyped up their new model, Mythos, by essentially saying, this is too scary to release to the public.
Right, a classic move.
They built this massive mystique around it being incredibly powerful and potentially dangerous. And of course, human nature being what it is, unauthorized users inevitably found a way to access it this week.
Though Anthropic claims no internal systems were actually impacted by the leak, the psychological seed was already planted.
Right. People wanted it because they were told they couldn't have it. But that specific marketing tactic caught the attention of OpenAI's CEO, Sam Altman.
Yes, on the Core Memory podcast.
On the Core Memory podcast this week, he ruthlessly mocked Anthropic without explicitly naming them. He said, it is clearly incredible marketing to say, we have built a bomb, we're about to drop it on your head, we will sell you a bomb shelter for $100 million, but only if we pick you as a customer.
This raises an important question. We have tech CEOs engaging in this hyperbolic warfare, comparing language models to digital bombs that require $100 million shelters.
It's a bit much.
They're projecting an image of omnipotent, dangerous intelligence. Yet when we look at how AI actually operates when embodied in the physical world, the reality is entirely different.
It is the ultimate reality check. Because while Sam Altman and Anthropic are arguing over digital bombs, there was a half marathon in China this week that featured physical robots running alongside human runners.
Which is such a funny juxtaposition.
And yes, to be fair, 4 of these robots finished the half marathon in under an hour.
Which is incredibly fast,
Yeah.
Significantly faster than human runners on a flat, predictable track.
Faster than humans, absolutely. But the event was full of hilarious, spectacular failures of basic logic.
Oh, it was a mess.
One robot looked like a drunk person stumbling side to side the entire time. Another robot got its pabbing completely turned around and was running at full speed in the wrong direction.
Just blasting the wrong way down the track.
And the absolute best one there was a robot that encountered a piece of tape on the ground. Just a standard piece of masking tape on the track.
Oh, no.
It couldn't figure out how to step over it. Its internal pathing logic completely failed, and the machine essentially exploded into pieces right there on the track.
It perfectly illustrates something called Moravec's paradox. High-level reasoning requires very little computation, but low-level sensor motor skills require enormous computational resources.
That makes total sense.
We have mastered the digital latent space.
Right.
AI can perfectly simulate a complex Mac desktop or coordinate a 300-agent coding swarm because the rules of code are rigid.
Right.
But physical common sense, like understanding the physics of stepping over a flat piece of tape, remains a monumental challenge for artificial intelligence.
We're treating these language models like digital deities that need $100 million bomb shelters, but the physical embodiment of this tech literally explodes when it encounters masking tape. It really puts the Silicon Valley hype cycle into perspective.
It's a vital reminder for you, the listener, to separate the marketing rhetoric from the actual, tangible utility of the tools.
Absolutely. So what does this all mean for you trying to navigate this massive wave of updates? If we distill the key takeaways from this entire stack of sources, the overarching lesson is that the AI ecosystem is rapidly maturing into actual utility.
It requires significantly less hand-holding now. With tools like GPT 5.5, token efficiency and contextual awareness are replacing exhaustive prompt engineering.
Thank goodness.
The technology is moving from being a passive responder to an active, independent agent through platforms like Warp and open-weight models like Kini.
Right.
And crucially, it's moving from generating flat aesthetics to generating functional, real-world assets, like the scannable barcodes in Images 2.0 or the interactive UI in Claude design.
It is an incredible shift. So in terms of how you apply this today, the immediate actionable advice is to just stop over-engineering your prompts.
Yes.
Unlearn the habit of writing 10 paragraphs of context. Allow the systems to do the heavy lifting. Start with a vague intent, Let the AI leverage its contextual awareness and see what it infers before you try to micromanage every parameter.
So as you reflect on all these advancements, what stands out to you in?
Is it the 300 agent coding swarms? The mathematical precision of perfect barcodes? Or maybe just the tape-exploding robots? I want to leave you with a final thought to mull over. If a model can infer your daily schedule, intuitively critique your dietary habits based on months-old chat logs without you asking, and generate mathematically functional barcodes from thin air, at what point does AI stop being a tool you use and start becoming an environment you inhabit? We started this deep dive by talking about how AI used to be like a highly literal dictionary. You had to learn its language, but now it's learning yours. It's reading the room, it's anticipating your needs, and it's building the room around you while you speak. Thank you for joining us on this deep dive, and as always, stay insanely curious.